Hello, everyone. My name is Will Aldridge, and I'm an application engineer with Parker Lord. I'm currently based on the West Coast of the United States in the great state of Nevada. I'm out here helping to support our electronic materials and thermal management customers with virtual as well as on site technical support. So today I am joined for this presentation by a special guest. I'll go ahead and let her introduce herself.
Hello, everyone. Thank you all for joining today. My name is Carmen Wimberly, and I'm currently a senior chemical technician based out of the Wixom location that's located in Michigan. I have been with Lord for the past 3 years, where I mainly focus on testing within the structural adhesives division, where I support several application engineers with their different customer needs.
Wonderful. Thank you so much for joining us, Carmen. This is the last session. It's kind of surreal to say that, the last session of the Thermal Management Virtual Academy series. So this is TM 501, and we'll be covering urethane and acrylic properties. So the specifics, the itinerary for today. First topic we're going to be touching on is what are acrylics and urethanes, as well as where they are used. Next, we'll be transitioning on to a high level overview of what 1K or one component products are in comparison to 2K or two component products. We'll also be talking about common material properties for acrylics as well as urethanes and why those properties are important to know. And last but certainly not least, we'll be talking about acrylic and urethane thermal management solutions that Parker Lord offers, as well as applications that they can be used in. Now, before we dive into the content, I want to let you guys know that we are on Twitter. So you can follow us at Lord Corporation, where we will be providing some comments and some information regarding this presentation. So we are live tweeting it. And so please join us using the hashtag Thermal Management 501 to share your thoughts and join in the conversation taking place on Twitter. So Parker at a glance, a high-level overview of Parker. There are over 3,000 plus different product lines that we offer, and we were based in 50 different countries. So a little background on how we came into the fold with Parker Hannifin. Parker Lord was acquired by Parker Hannifin back in 2019. So we have since transitioned into being a company known as Parker Lord. And so, as I mentioned, over 3,000 different product lines, and we're based in 50 different countries. So if you have an application that requires some of the services that we offer, we are absolutely there to provide it. And we really are a global business with a local focus. Now, when it comes to Parker Lord's manufacturing facilities in the United States, they are based in Sagertown, Pennsylvania, as well as Indianapolis, Indiana. Now, internationally, we have manufacturing facilities in Brazil, Germany, China, as well as Japan. Our expertise when it comes to our entire company is we really provide solutions for whatever application you're looking for. So, as you know, the reason why you're here, we do offer thermal management and electronic materials. On top of that, we also offer adhesives and coating solutions, as well as we provide sensing systems, as well as electromechanical motion and vibration control systems, as well as just kind of standard motion and vibration control systems. So those are the key products, but we really do service all markets. There's not really an industry that we aren't involved in. The industry that we are the most heavily tied to, though, is the automotive industry. So whether that's the new trend with electric vehicles, the electrification trend, or the traditional combustion engine vehicles, we are very heavily ingrained in both of those. Now, even going further than that, we're also involved in the energy and electronics world, and we also service the marine, industrial equipment, aerospace and defense, and oil and gas industries. So, as I said, we do offer quite a few different chemical solutions, and we are one company, but we offer many different chemistries. 2 weeks ago, Micaiah joined us to present on our silicone products. Last week, Nick joined us to talk about our epoxies. So we have the last two products left that Carmen and I are going to be covering. and that is urethane and acrylics. Now, I'm not going to really cover too much on this slide here, but it's a great overview of kind of the high level strengths and weaknesses of each respective chemistry. So feel free to take a screenshot, but we're going to be diving deeper into each of these products as we go throughout the presentation. So the first chemistry that we're going to be talking about is acrylics. And so we'll be highlighting the characteristics of acrylics. Where can acrylics be found? On a day-to-day basis, we interact with acrylics and we don't even realize it. For example, the plastic optical fibers that are in the fiber optic cables that deliver us our internet, our cable, and our phone services to our homes and businesses, those have acrylic-based products in them. Additionally, the cars and the buses that we use for transportation and the floors and roofs of our homes and businesses have coatings on them that are acrylics. Our favorite small businesses, or even the businesses that we currently work for, have signs as well as windows and plexiglass that are acrylic based. And then if anyone has a motorcycle like I do, the helmets that we use to protect our head while riding a motorcycle or even a bike, they have visors on them, and those visors are made of acrylics. So truly, acrylic materials are everywhere. Next, we'll be talking about the actual properties and advantages and disadvantages of acrylic chemistry adhesive products. So the advantages for acrylics are that they offer great adhesion to metals, composites, and thermoplastics, all while requiring minimal to no surface preparation. They're also great because they offer a room temperature cure. There's no absolute need to have heat involved in the curing process. They offer very short working lives, as well as they develop strength quickly in comparison to some of the other chemistries that we provide as a result of the free radical polymerization that is taking place inside the chemistry, kind of the background magic that makes it all happen. They're also very chemically resistant, as well as they offer high impact resistance. Some of the limitations are that they do not smell very good, so they do have a strong odor, that acrylate smell, and generally they are not repairable. Now, it's also worth noting that even though they're not repairable in their typical sense, if the cured acrylic products are paired with our lock release product, they can be used in they can be repaired, and that lock release can be used to help rework acrylic chemistries that have already been cured. Moving on to acrylic glass transition temperature and the coefficient of thermal expansion. Generally speaking, the glass transition temperature, which is very closely tied to the coefficient of thermal expansion, is one of the most important properties to consider when selecting a adhesive or thermal management solution. Now, I touched on the definitions of glass transition temperature and coefficient of thermal expansion a couple weeks ago during our technical terms course, but I also wanted to touch on them here, just give a high level refresher of what they are. So in case you missed those presentations and you didn't have the opportunity to go back and listen to them yet, you'll know what they are. So the glass transition temperature is the temperature at which a material transitions from being firm and glassy to pliable and rubbery. And the coefficient of thermal expansion is the relationship between the fractional change in size and temperature change. The glass transition temperature is known as the TG, and the coefficient of thermal expansion is known as the CTE. So the glass transition temperature can be influenced by cure temperature. That is the predominant thing that impacts it. So most acrylics are room temperature cured, but the post bakes can be added to that room temperature cure, or even just in general. They can be added to increase that glass transition temperature, because that glass transition temperature is the temperature in which properties begin to change. So above the glass transition temperature, mechanical, thermal, electrical, and mechanical properties are going to be a little bit different, and below they're also going to be different. So super important to keep in mind, but that glass transition temperature can be kind of customized to your specific application by adding a post bake. Now, crossing over that TG, as I said, can lead to changing of properties. The coefficient of thermal expansion is the leading cause for acrylic failures because delamination of the substrates oftentimes occurs, especially when bonding two dissimilar substrates. So, a metal and a thermoplastic both have different inherent coefficients of thermal expansion. So, when they're expanding at different rates, the delamination does oftentimes occur. So, two super important things to keep in mind when thinking about acrylics. So next we'll move on to one component versus two component acrylic solutions. So as I mentioned during the introduction, 1K stands for one component and 2K stands for two component. The one component solutions are when the A side and the B side, so the resin and the hardener, are already premixed. So they may use heat cure or they may use UV cure. So generally speaking, UV cure is super fast, but requires open head space, clear substrates, and or limited thicknesses for UV light to penetrate into the material. So that's something that's worth noting for the UV cure. Now, when it comes to acrylic 1K solutions, there are a limited number of options. So predominantly, the acrylic solutions that we offer are two component. So the resin as well as the hardener, so the A side and the B side, are stored separately. In the photo to the right, you can see that for the MaxLock MX-T6. You can see a dual barrel cartridge that houses the resin and the hardener. So typically these two component solutions are room temperature cures. So they cure at ambient temperature. They're quite common for household applications as a result of that ambient cure just being very easy to fit into processes and easy to fit into your manufacturing situation. Now, as I mentioned in the last slide, you can use heat to accelerate the cure and raise the glass transition temperature of these products. Now, generally speaking, for acrylics, we're able to divide up our adhesive solutions into two categories. One is the UV cure, and the other one is general purpose and thermally conductive. I mentioned that the 1K solutions can be UV curable, and so that is the case for our acrylic 1K solution. So it is Lord AC 902 LC, and it is not thermally conductive. So that is going to be the only product that we offer right there that is a 1K solution. Now on to the 2K. So we have thermally conductive options, which the leading one is CoolTherm TC 2002. And we also have quite a few general purpose non-thermally conductive solutions, such as Lord 5206 55GB, the entire MaxLock series, and the Lord 800 series. Now, diving a little bit deeper into ultraviolet UV cured adhesives. So, what is happening that makes that UV cure possible? Why aren't all adhesives able to be UV cured? The reason why UV cured solutions react the way they do is because they contain a small amount of photoinitiator that triggers the cross-linking reaction, thus changing the chemistry from a liquid to a solid state when exposed to those high intensity UV lights. So some of the high level properties for AC902LC are that they are one component. It's a one component solution. It offers excellent adhesion to plastics and metals. It has a cure of up to 10 millimeters deep, so your bond line thickness can be 10 millimeters deep. And it also has the ability to be used with just very common energy efficient LED lamps. So it's optimized to be used specifically with those type of lamps. And it also fluoresces under high intensity UV light so that you can ensure that it is actually applied and actually, where you need it to be during your manufacturing process. So that's a cool little feature, and you can see it in the image to the right on the bottom there. It glows, which is pretty neat. So AC 902 LC applications, oftentimes used in electronic vehicle battery module assemblies, and can also be used just in general battery module assemblies. It can be used as a potting for electronic components, as well as a dielectric sealant or coating. Next, on to Cooltherm TC 2002. Cooltherm TC 2002, it is one of our thermally conductive adhesives and the only thermally conductive acrylic adhesive that we currently offer. So the applications that Cooltherm TC 2002 can be used in are in battery modules, battery packs where the cells are bonded to the cooling plate. They can be used in applications where there's a high discharge and recharge rate that can raise the temperature of the battery, so that thermal conductivity helps to take that heat out and extend the life of the product there. And it can be used in applications where there are higher temperatures, like I said, that have the opportunity to shorten the battery cell life there. Some of the key properties of TC 2002 are that it comes in a 10-to-1 mixed ratio by volume. The thermal conductivity is 1 watt per meter Kelvin. It has a mixed viscosity of around 500,000 centipoise, so it does dispense like a bead, which is something that is very valuable. It is UL 94 V0 rated, so it does have the ability to withstand a flame. It has an open time of 7 to 8 minutes and will reach a handling strength in 20 to 25 minutes when cured at room temperature. It also offers excellent adhesion to metal and provides a high dielectric strength. So why would TC 2002 be chosen for a specific application? It acts as a thermal link, so it allows you to design and optimize your cooling design system. Another reason why it would be chosen is that it provides a structural bond and it has the ability to reduce the amount of mechanical fixturing that is needed because it truly is a two-in-one solution. You can have this product that has thermal capabilities as well as makes things stick together, or you could have another option that could be pursued is that you would have to have two products in there. So one that offers thermal conductivity and then one that bonds. So this is really a two-in-one solution. It's a one-stop shop for both of those applications there. Now, where can Lord acrylics be found? When it comes to thermal management material, so the TC 2002, it's oftentimes found in battery packs, in electric vehicles, electric aircrafts, electric marine applications, as well as energy storage units for whether it's home storage or even grid level storage. It can also be used to bond together structural joints. On top of that, the general purpose Lord acrylics can be used in heavy duty trucks or even ambulances, sign assemblies, storage containers, as well as home appliances. Now, I'm not going to dive too deep into this slide here. This is just a high level overview of some of the products that I alluded to during this acrylic section. So as I said, the Cooltherm TC 2002 is the thermally conductive solution that we do offer that has an acrylic chemistry, so its thermal conductivity is 1 watt per meter Kelvin. And then the UV curable is the AC902LC. So feel free to take a screenshot of this, save it for later, and you can go ahead on lord.com and go to each product's specific technical page, and you can find the technical data sheet and the safety data sheet for more information on these products. Now, acrylic takeaways. Some of the high level things that are the most valuable things that we alluded to. They offer great adhesion to metals, composites, and thermoplastics with minimal surface preparation. They also offer a very fast cure at room temperature, provide medium to high strength as well as medium to high strength hardness. They are excellent for low and high temperature applications. So super valuable there. Now, one of the main limitations that I mentioned earlier is it does have a strong odor. So that methacrylate smell is quite strong. And Lord also does offer a thermally conductive acrylic adhesive as well as a UV curable adhesive in TC 2002 as well as AC902LC. So next, I'm going to hand it off to Carmen to highlight some of the key characteristics of our urethane products.
Thanks, Will, for the great summary of the acrylics products. For the second half of this presentation, I'll be discussing our urethane product highlights with you all. Lower urethanes have a variety of characteristics that can be catered to many different customer application and needs. Some properties that come to mind when thinking of our urethanes are they can have a range of soft to hard, they have a short pot life, low viscosity at room temperature, which makes it very easy to dispense and spread, and they also provide good adhesion. In the future, when going over your options for application, if you hear such things as the operating temperature won't be that high, I need something good, I need something with good adhesion, but isn't too hard. I want a soft material, but not necessarily a silicone. I need a short pot life, or I need very low viscosity at room temperature. Our urethanes may be the solution you're looking for. Now I'll touch on a few of our main advantages for this chemistry. If you're looking to save some time for your application by skipping the step of applying a primer to your substrate, urethanes are still able to offer great adhesion even without this prep. They also have a fast gel time that occurs at room temperature, and it still maintains its properties even at low temps. They also have good flexibility and, as mentioned prior, low viscosity. They have a lower modulus and higher elongation, and we also have urethanes available that can also be used as a form of sealant since they can act as a great water barrier. While our urethanes do have many great properties, it also comes with a few limitations such as poor thermal capability, low to fair chemical resistance, and due to the isonate reactions within the urethanes, it's important to keep in mind their moisture sensitive nature when storing and applying this product. Early in our presentation, Will did a wonderful job of summarizing glass transition temperatures, also known as TG, and coefficient of thermal expansion, also known as CTE. I'll briefly go over their relationship to our urethanes. We offer both soft and hard urethanes, which provides a range of TG values. Soft urethanes typically have TG values of less than -40 Celsius, while the harder urethane TG are between 25 to 50 Celsius. It is good to note that if your operation goes through various changes in temperatures, that this will reflect with alterations in the urethane's properties due to the crossing over of TG. It is important to remember that the material becomes rigid below TG and a rubbery texture above TG. In terms of CTE, it becomes smaller below TG and larger above. Our soft urethanes have a larger CTE when compared to our hard urethanes. For that reason, our soft urethanes can avoid problems that our hard urethanes may encounter, such as cracking when undergoing thermal cycling or shock and delamination because of the changing of dimensions. We do offer our adhesives in both 1K and 2K packaging. However, our 1K urethane chemistries are limited. Our 1K adhesives can be cured with heat or UV lighting. Our two components include a resin on the A side and a hardener on the B side. They can be easily cured at room temperature or by using heat, such as a post bake, that will act as a way to raise the TG and accelerate the cure time if desired by the customer. Our urethanes can be used in several different markets. Some of our non-thermal products can be used in structural adhesive applications where bonding or sealing are top priority. Lower urethanes can make for excellent gap fillers. While these particular urethanes may lack in the strength needed for structural bonding, they excel transferring heat between substrates, making it an alternative to the traditional gap pads. Along with its thermal, electric, and mechanical potting properties, they also flow very well, which allows it to fill and squeeze into small spaces. If any of these potential applications sparked your interest, take a glance at some of the lower adhesives listed on the slide for these particular solutions. To put things into perspective, here's a short list of real-life applications that lower urethane products are used in. I'm sure everyone will be able to pick at least one item that you may encounter on a daily basis. They can be found in battery packs, charging systems, microelectronics, power electronics, sensors, LED lighting, automotive and marine craft assembly, and even household appliances. On the right, we have a few visuals of our urethanes in action, performing as potting solutions for a few of the examples I just went over, such as the LED lights and electronics. This chart is a great way to show our variations and properties of some of our urethane lines available that allows them to act as a solution to several different processes. Feel free to take a screenshot of this slide as a guide to compare the different classifications, viscosities, hardness, and working life, along with a few other categories that can help you find a perfect fit for your need. As the urethane section comes to a close, I want to reiterate a few highlights of our capabilities that I hope you are able to take away from today's training. Our urethanes can alleviate the hassle of applying primer beforehand and ultimately shorten your prep time by applying the product directly to the substrate while still maintaining great adhesion. It is best suited for applications ranging between cold to moderately hot operating temperatures. Our urethanes can cure soft to semi-rigid, allowing it to absorb any of the vibration and shock that a stress-sensitive electronic device may be exposed to. When fully cured, it can provide a barrier against moisture, also performing as a sealant. Its low odor can make the dispensing process a little more pleasant in the workspace. And lastly, the thermally conductive urethanes can make it a go-to for potting and gap fillers. That concludes the urethane portion of this presentation. I will be handing it back over to Will to discuss the next topic of coatings.
Wonderful. Thank you so much, Carmen. Now, with this last section, I'm going to be covering one of the key coating solutions that we have. It is our UV curing coating, which is Stipiol UV. It's a specialty material that is either spray applied or brush applied to create a very thin film-like material. One of the biggest selling points that we have for this is that it can be used to replace PET films on battery cells. So that's primarily where this product is going to be used. It provides high dielectric strength ratings and allows you to provide an electrically isolative barrier between components. So as I mentioned, this product is called Stipiol UV. It is applied using a spray gun to get to around a thickness of 100 to 150 microns. It is thermally conductive, coming in at 0.2 watts per meter Kelvin, and it, as I alluded to earlier, has a very high dielectric strength. It can be used with gap fillers or adhesives on heat sinks for added dielectric protection, and it also cures in seconds since it is UV curable. I mentioned some of the high-level overview of why UV technology works the way it does. So this technology, Stipiol UV, does contain similar behind-the-scenes magic that is going on. So to tie everything together, some of the key takeaways from this presentation. Acrylics, which often come in the form of structural adhesives, cure quickly and provide an excellent bond with minimal surface preparation. It's also worth noting that Lord does offer a thermally conductive acrylic structural adhesive. Parker Lord offers acrylic adhesives that are also UV curable. Urethanes are very, very diverse chemistries, but they also cure quickly and operate best at the lower temperature range. Urethanes can be used as adhesives, pottants, and encapsulants, as well as gap fillers. Those gap fillers are a replacement for the traditional incumbent product, which are gap pads. As well, the last thing that we touched upon there was that coatings can be used in applications where electrical isolation is necessary and needed. So the Stipiol UV product can be used as a replacement for traditional PET film. And Parker Lord, as you can see from the presentations that you were able to attend and even from this presentation, Parker Lord is a one-stop shop for all your thermal management, adhesives, coating, and specialty chemical needs, regardless of what your application is. So with that being said, Carmen and I would both like to thank you for joining us for this presentation today. And on behalf of Micaiah and Nick, we would like to thank you for attending some of the previous sessions. We hope you found this very helpful. And with that being said, we would like to open the floor for questions. Thanks for joining.